All right, so today we're going to be taking a look at the second half of section 7.3, the shell method. So the focus today is going to be when it is we should be using which of the two methods, disk versus shell. So here's 4 different picture examples of rotating around vertical axis of revolution and then horizontal axis of revolution. And here you can see with this one, we're in terms of y, so this is like an f of y function. Here with this one, our dx means we're at f of x. Here we're another f of x, and this last one here would be an f of y. So between the two, you're going to want to use the disk method when the rectangle, so that thing that you are rotating around an axis of revolution, when the rectangle is perpendicular to the axis of revolution. Because whenever that rectangle sits perpendicular, like this one here, this is our axis of revolution. We're sitting perpendicular this way. As we rotate around, this one's going to end up being a disk method. It's just going to end up having a hole in the middle, so it's actually going to be a washer, but washer's just a form of disk. So this one here, we're looking at a disk method. And then this here, as we rotate it around the x-axis, this rectangle here is perpendicular to it. And just like it was in the first one, we're going to end up creating a disk. It's just going to be a disk with a hole, which is going to be a washer. But we use that disk method that had just the pi out in front of the integral, and then the limits of integration and the big r squared minus the little r squared and so forth. For your shell method, you're going to be using the shell method when the rectangle is parallel to the axis of revolution. And that you can see then on these last 2 examples. So here our rectangle is parallel to the axis of revolution here, which is the y-axis. So now as we bring it around, it's going to create this cylinder with a hole in the middle. Same thing then here on the second one. If we're rotating about the x-axis and we have this rectangle that sits parallel, as we take and rotate it around the x-axis, it's going to create a cylinder laying on its side with a hole in the middle of it. So these are going to be your shell methods. And remember, with your shell method, these are the ones that have the 2 pi out in front. We needed the p, the h, and then the dy or the dx. All right, so we're going to run through a couple of examples looking at the difference between the 2 methods and when to use it, and just a little bit more practice on solving each of these. So the first one here, it says that we're supposed to find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, and x equals 1. So here is our y equals x squared plus 1. The x-axis is going to be your y equals 0, the y-axis is x equals 0, and then this line here is your x equals 1 line. So it bounds this blue shaded region. So for this first one, if we are going about the y-axis like this, and we create rectangles that sit perpendicular, if we do it like this is going to end up being our disk method. So we are going to use disk for this one to solve to find that volume that's found or that's created. So first off, notice if we're measuring out this direction from the y-axis, we're actually going to have to divide this into 2 separate pieces, because the distance here, the radius that we're going to have, is going to be a constant, whereas once we get to y equals 1 and above, we have a variable radius, so it changes as we move up and down. So we're going to need to chunk this into 2 different pieces. All right, so if we start with just this bottom one here, we know that we're going to have a pi. We're going to go from because we are in terms of y measuring out from the y-axis, we're going to need to do our integral along y. So we're going from 0 to 1. And now here, remember with your disk method, it was the big R squared, and our radius here is just a 1. So we're going to have a 1 squared, and then we're in terms of y, so dy. Then we're going to have to add to it the volume that's created from this top part. So we're going to have that pi again because we're dealing with the disk. This time we're going from 1 to 2. And now to find our radius, this one's actually going to end up being a washer because we're going to have part of this piece cut out in the middle. So we're going to have to take our big R squared minus our little r squared. And they show on here, the little r is this distance here on the inside. The big R is the same big R that we had on the bottom part. That radius out is just a 1. So we're going to end up with a 1 squared. That's our big R squared. Minus our little r squared, and our little r squared is this function. But because we're in terms of y, this needs to be an x equals equation. So I would need to subtract the 1, so y minus 1, and then square root it, which is what they have here, the square root of y minus 1. That is our little y. And then we square it, and then this whole thing here is dy. So just to kind of reiterate and recap on this, for this piece here, we had a big R of x equal to 1, and here was our R of x getting squared. And for this piece here, because it is a washer, we're going to have our big R of x, which again is just a 1, and our little r of x, which we got by solving this for y, which is the square root of y minus 1. And then here, this becomes the big R of x squared minus the little r of x squared. So we've got our disk, we've got our washer. All right, so if we continue on then and just do the calculus work to integrate, first thing we need to do is square it. So this is going to be pi times the integral from 0 to 1. 1 squared is just 1, so I'm just integrating 1 dy. Here I've got my pi out in front. I'm integrating from 1 to 2. Here a 1 squared is a 1. And here a square root of y minus 1 squared is just going to be the y minus 1, but it's minus it. So minus the quantity y minus 1 and then dy. On the second one here, the negative is going to distribute. The 1, oops, I'm sorry, no, it's going to distribute to make a plus. That won't cancel out. This is going to end up becoming a pi times the integral from 1 to 2. That's going to become a 1 plus a 1 to make it 2, and then minus y dy. And then we still have our pi times the integral from 0 to 1 of 1 dy. So now if I integrate, the integral of 1 is just a y, and I'm going to evaluate it from 0 to 1. So pi times y from 0 to 1. And then the second one's going to be pi. The integral of 2 is 2y. The integral of a negative y is a negative y squared over 2. Raise the power and divide by the power from 1 to 2. Here, if I plug in a 1 and then a 0, this is just going to be a pi times, we can write it as 1 minus 0, but it'll just be the 1. Plus pi times, and now here, if I plug in my upper limit, 2 times 2 is 4. Here, 2 squared over 2 is a 4 over 2, which is 2, minus the lower limit, 2 times 1 is 2, and a 1 squared over 2 is just a 1/2. If I plug this stuff in, 2 minus a half is 1 1/2. This here is going to be 4 minus 2, which is 2. 2 minus a 1.5 is a 1/2, times the pi would make a pi over 2. Here, the 1 times the pi makes a pi. A pi plus a pi over 2 is a 3 pi over 2. And so the volume that's created by rotating that guy around the y-axis is going to be a 3 pi over 2. Now we're going to do the exact same thing, except with a different method. So now instead of drawing our rectangles so that they are perpendicular to the axis of rotation, we're going to draw them so that they're vertical. So we're going to think of it this way. This time we are in terms of x's, and because we are rotating around the y-axis, it's going to end up creating that shell, so that cylinder with the hole in the middle of it. So when we do these, we need to know what our p sub x is, which is our distance from our axis of rotation, and that's just going to be an x as we move along. And here they show p of x equals x. The height of this rectangle is just the value of that function, and here they show that h of x is the x squared plus 1. So with our shell method, it was a 2 pi. We're going to go from 0 to 1 because we're in terms of x this time. P of x, which is x, times h of x, which is x squared plus 1, dx. If I distribute first before I try to do any integrating, I'm going to get a 2 pi integral from 0 to 1 of x cubed plus x dx, because I just distributed the x through. Then I'm going to have a 2 pi times, and now here, raise the power by 1 and divide by that power would make that x to the 4th over 4. And here, raise the power and divide would make that an x squared over 2, evaluated from 0 to 1. So I'm going to have a 2 pi. Here, if I plug in the 1, I'm going to have a 1 to the 4th over 1, or 1/4. Here, I'm going to have a plus 1 squared over 2, or just 1/2. Minus, and then if I plug in a 0, it's just going to be a 0. If I take a 4th plus a 1/2, that's going to be 3/4. So I have 2 pi times 3/4. And if I reduce here, I'm going to end up with the same 3 pi over 2. So you can come up with the exact same answer using two completely different methods. You just have to make sure that whichever method you're using the right formula and pulling whether it's supposed to be a radius or if it's supposed to be your distance p from your axis of symmetry, your axis of revolution, and then your h, which is the height of that rectangle. All right, so we're going to look at a couple more on the back side here. Example 2, they tell us to find the volume of the solid formed by revolving the graph of y equals 1 minus x squared over 16 from -4 to 4 on the x about the x-axis. So for this one, they're showing us where, excuse me, bless me, sorry. They're showing us how they want this rectangle here to sit. So here they've got the graph. This is the one minus x squared over 16. They're going from -4 to 4, and they're showing here this is going to be the rectangle. So if I take this rectangle and rotate it around the x-axis, it's going to end up making a disk. So that's the method that we want for this one. Whenever we do the disk is the one that's based off of a radius. So the radius of that disk that's going to be created is just the height of this rectangle, which they already have labeled as 1 minus x squared over 16. They do have the little r of x labeled, but really we wouldn't need it. That inside radius, there is none, so it's just a 0. So this one's going to end up following that formula, pi times the integral from a to b of big R of x squared dx. We know our big R of x is 1 minus x squared over 16. And we know that we're going from -4 to 4. So 1 minus x squared over 16 from -4 to 4 we already have, and then dx. All right, so, forgot the squared. First thing we're going to have to do is square this guy. Now, do keep in mind you're squaring a binomial, so you can't just take the first thing squared and then the second thing squared. We'd have to write it out twice and do all of our distributing. So we're going to get pi integral from -4 to 4. If I had this written out twice and first I distributed the 1 to the 1, I would get a 1. Here, a 1 times a negative x squared over 16 is a negative x squared over 16. I would multiply and get another one, so I have negative 2x squared over 16. The 2 and the 16 reduce to make a negative x squared over 8. And then the last one, I would have a negative x squared over 16 times another negative x squared over 16. The two negatives are going to make a positive. X squared times x squared makes an x to the 4th. And on the bottom, 16 times 16 is going to give us 256. And then dx. So we're going to raise the power and then divide by that power on each of these. So this 1 just becomes an x. This x squared is going to become an x cubed, and then when I divide by 3, the 3 I divide by is going to multiply by the 8 that's already there to make 24. And then here that x to the 4th raises to x to the 5th, divided by 5. That 5 will multiply the 256 that's already down here to give us 1280, and we're evaluating from -4 to 4. Now, going to have to grab a calculator and we'll start plugging in all these numbers. All right, so we're going to have pi. When I plug in a 4 here, I just get a 4 minus 4 cubed is going to give me a 64 over 24. Now, granted, those will reduce, but I'll let my calculator reduce it here in just a sec. Here, 4 to the 5th is going to make a plus 1024 over that 1280. That's my upper limit, minus my lower limit. So now if I plug in a -4, I'm going to get a -4. That's going to end up making a -64, and then that negative is going to turn it into a plus 64 over 24. And then here, that negative to the 5th is going to make a minus, and then the 1024 over 1280. And now I am going to plug all of that into the calculator and let it do the work. So I've got 4 minus 64 over 24 plus 1024 over 1280 minus a -4 plus 64 over 24 minus 1024 over 1280. And it ends up coming to 64 over 15. Combine that with my pi to get 64 pi over 15. And then now the last one, example 3. Example 3, we have got an equation y equals x cubed plus x plus 1. So we're looking at this piece here. The line y equals 1, which is here. X equals 1, which is here. And we're going about this axis, x equals 2. So this one's going to be a little bit different because we've got this gap in here. Now, if I were to do it sideways here, and I were to do it as if it were a disk method to create, actually it would be a washer because we'd have this hole in the middle, I would need to, because I'm going this way with it, need to be an x equals equation. The catch is with this particular problem is you can't solve this thing for x because of the way that it's set up. There's no way to take this and rewrite and solve it for x. So the only thing we can do is a vertical rectangle. And when we take a vertical rectangle and rotate it about this vertical axis, we're going to end up getting shells. So there's no way around it. We're going to have to do this thing with the shell method. So just a reminder here before we get going, shell was a 2 pi from A to B. We needed a P, and I'll do it since we're in terms of X, it's a P sub X and H of X dx. So P of X, H of X dx with 2 pi out in front. So for this one, our P of X is going to be the distance from our axis of revolution. If I just plug in an X though, an X is going to measure from 0 to the right as I move along in X's. But I want to actually start at 1 and go backwards the other direction. So the way that we're going to do this is if we take our axis of revolution and subtract X, now as I go through, because I'm integrating from 0 to 1, that's where this space is. So I can go ahead and fill in here from 0 to 1. So if I were to plug in a 0, let's see. Okay, sorry. I know this seems like an odd break. I had somebody come to my door, so let me backtrack here just a second to regather my thoughts to where I was before I had to pause the video. We were talking about this P of X value and the fact that we're rotating about this axis here at X equals 2. So what we're trying to figure out, this P of X is going to be our distance away. And since we're having to integrate from 0 to 1, if I put 2 minus X, then when I plug in a 0, 2 minus 0 is 2, so that means I would be 2 away, which is actually putting me back here at 0. Then as I move along, if I'm at X equals 1/2, 2 minus a half is 1.5, so now I'm 1.5 away from that axis of revolution. All the way then to whenever I get to 1, 2 minus 1 is 1, so now I'm 1 away. So by doing it as a 2 minus X, it's making it so that I'm starting out here and coming in to just 1 here. As for then our height that we have, the height of this rectangle, to call it just this function here, would start from the x-axis and go up. But I have this piece here from 0 to 1 that I don't want to include. So this is kind of like whenever you guys found the area in between two curves. I would have to take the upper minus the lower, and the lower here is going to be just this line, y equals 1. So my h of x is going to be my function, x cubed plus x plus 1, and then minus that 1 that's underneath that we want to take away. So now as we start plugging in, my p of x is that 2 minus x. My h of x is going to be an x cubed plus x, because the 1s are going to end up canceling out, and then a dx. So the first thing we're going to have to do is all of our distributing. So 2 pi integral from 0 to 1. Here, a 2 times an x cubed is a 2x cubed. Here, a 2 times an x is a 2x. Here, a negative x times an x cubed is a negative x to the 4th. And a negative x times an x is a negative x squared. Now, we could put these in order so that it's in a general form with the x to the 4th first, and then the x cubed, x squared, and x. It's okay, though, just to leave it. We're going to integrate, plug in numbers. It's all going to come out in the wash anyway. So we're going to have our 2 pi. If I go and integrate now, if I raise that 3 to a 4 and then divide by 4, I would have 2x to the 4th over 4. Here, if I raise that and divide by that power, that becomes a 2x squared over 2. Here, if I raise the power and divide, it becomes an x to the 5th over 5. And here, if I raise the power and divide, it becomes a negative x cubed over 3. And we're evaluating from 0 to 1. Now, if I start plugging in those values, my upper limit, 2 times 1 to the 4th is going to give me a 2. 2 over 4 reduces to a half. Here, a 1 squared is 1, times 2 is 2, and 2 over 2 is 1. Here, 1 to the 5th is just 1, over 5 is a minus 1/5. And here, a 1 cubed is just a 1, over 3 makes a minus 1/3. So if I figure this out, I'm going to have a 1/2 plus a 1 minus a 1/5 minus a 1/3, and that's going to give me the fraction 29 over 30. So I've got 2 pi times 29 over 30, and now if I multiply that 2, it's going to reduce the 30 to a 15 to leave us with 29 pi over 15. So you have to look and figure, is it going to be best to use the shell method? Is it going to be best to use the disk method? Everyone kind of has their own personal preference as to which one you think is going to be easier, but sometimes you will run into a situation where you're forced to use one over the other, like we were here in example 3, because there was no way to solve this and make it an x equals, so there was no way to turn this into a disk method, and we were forced to use a shell. All right, so you guys have 5 of these problems to work out tonight. It's on page 462, those 5 problems. After this lesson, we are going to be working on a review that kind of mixes all together the shell method and the disk method.